All right. My name is Lazar. You can call me Lucky. That's my nickname since childhood. Don't ask why. Long story for another day. Question. Who here is actually a programmer earning money writing code? Perfect. This talk is for you. It's about your past, it's about your present, it's about your future in this chaotic era of this thing, right? Who has seen this before? Let's talk about it. Huh? So, there's this theory, let's call it like this. Fact, that's the right word. So, if you write crappy code over time, you would not be able to write any more code eventually. And again, there's this theory, if you don't write crappy code over time, you will be able to go linear with the same velocity forever. Okay, so let's discuss what this has to do with AI. Well, if you are working, and maybe this is a good question, who here is working on short-term projects? So you build something, it doesn't matter, is it weeks, months, or a year, and then you give over the keys, and then you're done, you go home. All right. This is this place here. So it's short period of time. Here, I mean, this is clearly saying you should write crappy code. And yes, you should. I would also say that. Why? Because in a short term, you are actually faster. If you don't write your test, there's no architecture, you're just making this thing go. Like, this thing is true. This is where AI is great at. And you, sir, will be replaced. This is where AI shines. Prototyping, MVPs, things that need to kind of work. You know, like, oh, it looks good. I mean, it works. Perfect. For all the others, in the long term, this is where AI sucks. Sucks big time. Let me explain why. Because AI is doing exactly this over time. So the more you write in your project, the more you prompt, it will keep writing crappy code. What's great about AI in comparison is AI can just, you know, like, you have crappy architecture, then you want to do a feature, you want to execute a feature that requires re-architecting the thing. Well, you prompted, this thing goes crazy with these tokens, and then rewrite the whole thing again, and again, and again. I mean, it's a great idea, right? But where you will end up is to change a label in a corner of your page, this thing needs to spend 1,000 euros in tokens. We hope that in future this will be solved, but there are things that we did before, that we are doing now, and that we should do in the future to solve this problem. This talk is about cooperation with AI. It is not about all-in AI, all-in programming. Absolutely not. Okay, so I said we're going to talk about the past. Who here knows who this guy is? Awesome. Awesome. Woo! I didn't expect this at all. This is for the others, Dave Farley. This guy co-authored the book Continuous Delivery 2004, am I right? 2004, 2005. This is a Bible for all the DevOps, for everybody who wants to do anything regarding continuous deployment, continuous delivery, and much more, right? And he, wait back, come again. Yes, and he said something quite controversial. I'm going to read this, so that's his quote. I'm quoting him. I think creating software is a solved problem. I'm going to repeat that. He said, I think creating software is a solved problem. I've spent 15 years in this industry, last 10 years writing mostly mission-critical software, the thing that you mentioned before, where it needs to work. It's not enough, it just kind of works. I've done these things also, right? But when we talk these things that need to work, I agree. And now this slide. What? What he just said? Yes. Let me tell you a story. So, I don't know, 11 years ago, I was working for a software company that has, that's European leader in a certain area and world number 2. When I came, there was a 15-year-old legacy system, 5.5 gigabytes of source code, not a single line of test. And I come in this small team, and I try to do something, right? Like, I was stupid. I couldn't do shit. So there were these guys who were just, making progress really slow because we are definitely in this zone here, right? So there were guys moving, slow but moving, but I couldn't move at all. I was just like completely blocked. And then the imposter syndrome and all the other things that kick in for all of us. I was like, nah. I made a decision. To put my white belt back on, to leave everything I know on the side, and relearn every concept in programming from scratch. But not just from scratch. I decided to learn every concept from the author who created it, or from person who wrote it down, because sometimes the author don't write, and there's another colleague that just writes these things down. I read some old-ass books. I read books 50 years old. So in this process, I was like, oh, nothing is new. Oh, we've seen all of these problems. Oh, the AI problem. Oh, the artificial intelligence. Oh, that exists since 70s. But it was just discussed in small groups in IBM, in those big companies. So all the things that we are doing, people have done it before many times, but the fashion goes up and down. Strongly typed languages, loosely typed languages. Strongly typed languages again, loosely typed, and stuff like this. So I've spent a decade building, training, and leading teams that work like this. And I've seen it with my own eyes. I had amazing success in mission-critical software, in startups, in any project that I have ever tried, using those basic principles that we know of for 30 years already. I cannot unsee it. I've seen it work, I can't unsee it. In the era of AI, all of those principles are still valid. But let's embrace AI and help AI where AI is not that good until it gets good eventually. So let's talk about some of these things, right? And another question, who knows who this guy is? No. All right. This is Kent Beck. Kent Beck he will be studied in schools 100 years from now. He's like what Tesla is for electrical engineering, this guy's for software engineering. He's so creative, so intuitive, Genius. And he never got rich out of it. He's still alive, don't worry, alive and well, all good. Let me tell you a couple of fun facts about this guy. This guy is amazing. So he spent 17 years on a goat farm, milking some goats, doing some programming, milking some goats, doing some inventing and reinventing, like he likes to call it. Then again, milking some goats, and you see where this is going, right? Another fun fact is he spent 7 years at Facebook. That story for another day, right? But he was such a creative person. He gave us many things that you use, but you don't know. He is, as he likes to say, the reinventor of TDD. He wrote JUnit with his bare hands. All the name it unit frameworks came from this. He was one of the original Agile Manifesto signees. He created the only Agile methodology that we know it works. It's called extreme programming. We call it XP because horrible name. He said it also, like super hard to market to an enterprise. You know, like come in and like, we're doing extreme, like he knows. But too late now, so XP, right? He created at Facebook something they called 3X. I like to talk about this also, but this is more a business talk than a technical talk. He created, this is next level. So he decided to use technology on the next level to make TDD better. And he created something called test, commit, revert. He's using Git in combination with test first. Like, this guy is nuts, I told you. And in the last year or two, he wrote 6 books on architectural concepts about tidying first. Again, crazy stuff. And he's still playing. He's still using AI and playing this game. So, as I said, he gave us XP. And XP has a so-called XP circle of life. Anybody seen this before? Looks like what?
Spiral model. Somewhat.
Okay, let's go. This is super interesting. So these are practices that Agile teams, XP teams, use. And the outer circle, the red circle, I don't know if you see it's red, but the outer circle is Scrum. Anybody heard about Scrum? Yeah. This is why Scrum is not good enough, because Scrum only has business practices. The red circle is only business practices. These are great, but Scrum doesn't have technical practices that a team should do. So let's talk about those. The middle circle, the green one, is team practices, meaning these things are something that business people in a team and technical people in a team do together. And for today, the most interesting circle for us is the most inner circle. And there we have technical practices that all technical people in a team, programmers, QAs, DevOps, blah, 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 do. Let's read them out loud. Pair programming, test-driven development, refactoring, simple design. There's something interesting about this. About what simple design is, we'll talk a bit more in detail in just a second, but for now, when we say design, this word is exchangeable with software architecture. When I say architecture, I don't mean infrastructure. When we say architecture, unfortunately, this word is hijacked by DevOps these days. So when you say I'm an architect, everybody thinks like, oh, you're doing Kubernetes and you know, these kind of things, you're deploying our code. No. But then again, it's hijacked, it's over. In early days, before QA, before DevOps, architecture was, what you mean is how you structure your code. That's why design is a better word. So design and architecture is the same, but when we talk about the design, we talk about software architecture, not infrastructure, right? Good. So to be able to have simple design, you need to be able to refactor your code. Because simple design, great architecture, you don't start with it, you end up with it. There's a process to it. To be able to change your code, right? To be able to get there, you need to be able to change your code, meaning you need to be able to refactor. Who here knows who Martin Fowler is? Nice. Martin Fowler is the person who wrote the book Refactoring. Don't learn anything from YouTube, especially refactoring. There's a book called Refactoring, it costs, I don't know, 20 euros, written by this guy. There's a new edition in 2021 or 2. Actually, all the examples are in JavaScript. This is all you need to know, and it is explained from the best possible person. If you need a definition of something, a concept explained, Martin Fowler is your guy. So he wrote a book about refactoring. That's all you need to know about refactoring. The first sentence in the book says, every technique that you see here, you can use only if you have a suite of tests that you can trust with your life. Because by definition, refactoring is changing the inner structure of the code without changing the behavior of the code. What controls our behavior? Test-driven development. And test-driven development can't really be done without just a bit of design. That's why this circle is super interesting. But today, the most interesting thing in this circle is pair programming. I don't know if you are a fan of pair programming. I am, of pair programming, mode programming, all of those kind of things. There are studies that say that you are 15% less productive if you work in pair in comparison to two people working independently. But again, the same study is showing that those two people produce 15% more bugs. So you need to know in which game you live. If you live in this short-term game, then who cares? If you live in the long-term game, it's obvious. And again, I've seen it work. I cannot unsee it now. Story for another day. But today, pair programming is interesting for us because AI is the best pair programmer you can ever have. It's not giving you crap for anything. It's never tired. It's just doing everything you ask it for. Okay, super. Let's talk about simple design. Kent Beck defines simple design with these 4 rules. Your code and your design, it passes the tests. Okay, now we know it works, right? It reveals intention, so it is easy to read and easy to understand. In the world of AI, this is questionable, but we'll come to that. If you want your code to be easy to read and understand, the easiest thing you can do for yourself and your team is like take a standard, pick one. Pick a standard, and then everybody in the team is doing the same thing. Then everything is going to be the same to read and understand. If you need to pick one, pick clean code. By the way, clean code is not complicated at all. None of these things are complicated at all. If you hear anybody on YouTube or any platform where you're learning saying, oh, clean code is complicated, XP is complicated, TDD is complicated, that person has no idea what he's talking about. And wants to sell you something, wants money from you. So be aware of that. So let's go to the third rule, is no duplication. And you've heard of dry, right? Dry killed a lot of people and many projects. What he means by dry, there's 2 types of duplication. There's actual duplication or true duplication and accidental duplication. Let me quickly explain you what I mean by that. So we had an example before of there's a date coming in US format we wanted to have in German format, right? This is something that could be a little function, a utility function that you can use across your system. That's true duplication. You should not write the same thing over and over again, right? You can have a small function, give me US format, I'll spit out the German format, you have it in one place, awesome. But what if you have 2 API calls, 2 use cases, and you wrote them independently, and then you see, oh, there's code here and code here, it's the same. It looks the same today, in this point in time, but those are 2 use cases. You need to take a good look and think, is this thing going to change for different reasons than this thing? Because tomorrow, this duplication may not be there. Do not extract that, right? So he means true duplication, okay? Good. And the last one, fewest elements. Remove anything that doesn't serve the 3 previous rules. Again, you need to have the 3 previous rules and then you come here. This is also called KISS. Keep it stupid simple. Spoiler alert. Easier said than done. Okay. Who knows who this guy is? A lot of old folks here, right? Okay. This is Alistair Cockburn, and he is the author of Hexagonal architecture. He calls it actually ports and adapters architecture, but he actually calls it ports and maybe adapters. This QR code here is a link to a recent talk he gave to, it was an online conference, and he explains in 30 minutes hexagonal architecture. If you go to YouTube or GitHub and look for hexagonal, you will see monstrosities, over-engineered code, something that nobody can understand. This guy explained it beautifully and elegantly. This thing is so simple, it is actually beautiful. At the beginning of the video, he will give you a little challenge. He would give you a slide, and he would say, write this down in your code now. And you do this, and that's it. It is marvelous. It is based, this architecture, okay, now I need to say more. So, hexagonal architectures, ports and adapter architecture, clean architecture, onion architecture, plugin architecture, list goes on. Many names for the same thing. Actually, the first written material on this topic is from Ivar Jakobsson in the year 1991. That's long ass time ago. All right. This is based on something, on a simple concept called dependency inversion principle. Heard of it? Okay, this is, I promise you, super simple. How many front-end programmers here? And the rest are back-end or? Okay, so I'm gonna do both, but let's go with the front-end example. So let's say we are now in the realm of rigid. So let's say this A thing here. Let's imagine that A is one of those on-click functions. So you have an event, on-click, and then you call the function A. And this function needs to do something, okay? This is simple enough, right? Okay. So let's say this A function needs to take some stuff from the page, reorganize, prepare, format, I don't know, and send an API request to backend. Simple enough? Simple enough. Let's say that B is some code, a function. Let's say this is a fetch call, right? So far so good, right? My function doing something, calling fetch, life's great. Then CTO comes, or one of those architects who don't code, right? And they're like, we need to go away from fetch. We need to go with Axios. Ever seen this situation again? Okay, I did. And then, now B is not fetch, it's Axios. Now A needs to change because the response is packed differently with Axios. It's doing the same thing, but you need to change A, but you changed a detail here, right? So the dependency inversion principle is saying the high-level abstractions should not depend on low-level implementation. Meaning, my business logic, what my program is actually doing, what I'm earning money from, should not depend on some external tools that I use to achieve this goal. That's what this is all about. So the dependency should be other way around. How can we do this? we can do it like this. So now we're going to explain this thing. I also want to give you one more quote. The best architecture, software architecture you can have, again, not talking about the infrastructure, talking about software design. The best software architecture is the architecture that lets you make decisions later. I'm going to repeat that. The best architecture gives you the possibility to make decisions later. Imagine this scenario. Still, we have our onClick function doing our business logic. Perfect. And then we say this function is calling an interface that we define. So I'm going to create an interface, let's say TypeScript interface, and I'm going to say there's a function called post, right? And then I'm programming A with this thing in mind. By the way, I defined it together with A. This thing belongs together. And then, when you call A, you can inject a function or a class that implements this interface, right? There are many ways to do this these days. And then you will actually inject the implementation there. What's magic about it? So there's going to be in B some code that will implement what you want here using fetch. And then the CTO comes and like, Axios, okay. I come here, I change this code. This is a contract, this is not changing. A does not know that B exists. Doesn't know where is it. Doesn't know what is it, how it's doing it. Like what the hell, like, don't care, detail. I can make this decision later. I can have one programmer writing this, or one team writing this, and other team writing that. The implementation has no idea who, where, and how will use it. Now, A and B are separately deployable. You know, in compiled languages, you can deploy these things separately. Separately testable, because there's an interface between them, we can mock this. And it is separately developable, what I just explained. So this is the front-end example. But let me show you a back-end example because it shows more possibilities, what can we do with it. And we can talk more about AI here. Is this big enough? Is this better or this one? Okay, let's start with this one. So there's a browser sending, you know, www.yourwebsite.com. There's a, let's say, single-page application, React, Angular, Svelte, whatever you kids like these days. And then this thing is sending HTTP calls on your API controller layer. Any questions about this? Yeah, simple. Okay, so now we don't need this anymore. We can focus on what's happening in the backend part of it. Okay, so controller receives a request. And then the only task of a controller or a handler, depending on the language you're using, a framework you're using, right, should be this. Controller receives request, packs the request in the defined request object, calls somebody to execute the work, get the result, send it back. One more time. Controller receives the request, packs that request into an object, calls somebody to do the work, and then return the response. Controller doesn't care who, how, and where we'll implement this. Good. So now, what's happening after? So now, different team comes and like, oh, this is our task. People, we have here a couple of function signatures, we need to implement this. Let's go. And then this team receives this object, and let's say this is a put request, you need to update some information from the front end to the database. Nice. There's this, you know, like this is basically JSON, key value pairs, like simple object. So now we're like, yeah, let's parse this thing into an entity, because in HTML, now comes something controversial, everything is a string. In HTML, there are no types, right? What you see on the screen in your P element is a string. So most probably we'll have a date that's a string here. But in the database, I need this date to be an object. Pick your language, right? And then this use case is parsing this data from no types to types, calling an interface that needs to save this, or actually update this thing in the database. You noticed use case has no idea which repository framework are we using, which database. Is it a database? Is it an SQL database? Is it a NoSQL database? Is it a file? Is it object in memory? Doesn't care. Not important. Detail. A team can come and say, we don't like Prisma anymore. We would like to use a different thing. We don't like ORM mappers. We would like to write our SQL on our own. Perfect. You just implement this thing. Use case, controller, all this other part, they don't care. So you can do this completely separately. The same with external systems, right? Let's say my use case needs to call ChatGPT API to ask a question. Awesome, right? I'm just going to define what I need, right? And then I can write there something that makes sense for the use case. Then now comes the word adapter. You remember from before, ports and adapters. Now comes the little code that's actually calling some external API, right? And guess what? Let's say I want to change from ChatGPT to pick one, Gemini, I don't care. Yeah, super. We're going to change that. Everything stays the same. So what you can notice here is I drew these red lines. Everything inside those lines is pure programming language of your choice. There are no frameworks inside. There are no basically libraries inside. All of this thing you can take anywhere and change your frameworks and externals and everything. And this will live forever. So this is something that we can use, so we should have been using in the past. Shoot me if I know why rarely I see this. Super rarely. This is super simple. So today we should use it, and especially today with AI. This is now the key. You can come here. There's this function signature. This is your input, this is your output. This needs to be built. You want to create a border here, a port for the database, right? You write the tests from here to here, your tests. And then you say, dear ChatGPT, Gemini, Claude, whatever, execute. 20 seconds later, you have your use case written. So two things. This type of architecture, write your tests first in your boundaries, and then let the Claude or any weapon of choice do this to you. This is where AI shines, because it's super small context. You defined what you want, life's good. Let me tell you from experience. I don't know for non-programmers, but for a programmer, it's way easier to just write your requirements in your tests as given. Anybody using Jest? Like, it's super easy. You just write your requirements in the format given, when, then. I lose so much time and nerves prompting. This is slow. It's not good enough for me. If I write those tests, and then I go and I ask your weapon of choice, AI weapon of choice, and I ask, did I miss something? Inspire me, give me more things, check if I missed something. And then I write it down. And then I just say, execute, baby. Boom. 20 seconds later, you have it. This is opportunity. AI is going to be better and better and better, and at some point it's going to be perfect here, really soon, maybe months away. Awesome. It's awful at building this, because for this you need to talk to your team members. You need to talk to your product owner. Product owner needs to explain you. Your users need to explain you. What do we need? How are you going to do it? Like, you need some creativity here. AI sucks at this. But let's say it's going to be great at it at some point. Good. Not a problem. Less work for us. But one thing stays still. I don't trust it that it will build me a system that I want to use in my car, in my plane, or whatever. I'm just going to write tests for it. So I'm going to have less of the layers, because this can get big, right? You can have many layers stacked, right? You will have less of that, and still you will have the result you can trust your life with. So yes, use AI to do your work, because now that's boilerplate. When you know what you need, I don't need to know bubble sort. AI needs to know bubble sort. I need to define, I want this thing sorted. Please do it for me, come on. You remember, maybe you know, there's this saying that as long as managers don't know how to explain what we need to do, like, we're fine. As programmers, and AI, it's the same problem with AI. People need to explain what they want. So I can tell you from my own experience, still, till this day, I'm way faster writing my own tests and saying, AI, do this for me, in comparison to just do everything for me. Because prompting is changing at the same pace as AI is. I'm having struggles with prompting. And discipline in prompting is hard to, like, this thing is super simple. Given this, when that, then this. Boom, 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 boom. Give me more examples. Boom, we're done. I encourage you to try it. Go play. Just try it. It costs nothing, zero, right? You can take any model, play with this. You can literally go, and you don't need to have any fancy tools. You don't need to pay for cursor. You can literally copy your test file and then paste it into ChatGPT and say, give me the result in any language. And you paste it back into your implementation, and you know it works. How? You run your tests. Oh, it's green. Awesome. Spoiler alert, when you write TDD, that's next level. The TDD is not just test first. TDD is every line of code is there for a reason. If you move lines of code, one test will fail. What I've noticed when I write all of these things first, AI writes more code than necessary. I can do mutation testing. This is a technique where you remove some lines randomly and then you check if some test will fail. So yeah, it's not perfect, but it's good enough. It's good enough. I mean, ask yourself, what do I have to lose, right? And I was planning to do this session as a coding session, where we could program together in TDD with this architecture and then call, but maybe we could organize this some other time. I just wanted to give you like a glimpse of it. I mean, what do I have to lose? Just live coding, right? Nothing can go wrong. So for any questions, hit me up on LinkedIn. If you want to hear more stories, just contact me, let's do it. If you want me to talk at your event, let's do it. The most important thing, if you want to tell me your stories, please contact me on LinkedIn also. Thank you.